Hello, today we are covering lesson 12.5. It's about volume of pyramids and cones. So this is how we derive our equation to find our volume of our pyramids. A triangular prism can be separated into three triangular pyramids as shown. So we have the yellow, the green, and the orange pyramids. Since all faces of a triangular pyramid are triangles, any face can be considered a base of the pyramid. The yellow and the orange pyramids have base area B1 and height H1. Therefore, by Cavalier's principle, they have the same volume. Likewise, the yellow and green pyramids have base area of base 2 and height H2, so they have the same volume. Since the orange and green pyramids have the same volume as the yellow pyramid, it follows that the volumes of all three pyramids are the same. Therefore, each pyramid has 1/3 the volume of the prism with the same base area and height. This is true for a pyramid with any shaped base. So that's where this equation comes from. The volume of a pyramid is 1/3 the area of the base times the height. So let's find it. Find the volume of the triangular pyramid. We are going to have to find the area of the base, multiply it by the height of the 3D shape. It has to be the perpendicular height, and then we divide it by 3. So I like saying the base times the height divided by 3 instead of 1/3 times the base times the height. Now our base equation, since it's the area of the base, we take 6 times 15 divided by 2. We end up getting 45 for that. Then we multiply 45 times the height of the 3D shape. So we get 630 divided by 3, which gives us 210 cubic feet for our volume. Pretty simple, actually. Let's try another one. Brad is building a model pyramid for a social studies project. The model is a square pyramid with a base edge of 8 feet and a height of 6.5 feet. Find the volume of the pyramid. So, first of all, I want you to imagine a pyramid that's 8 foot by 8 foot by 6.5 feet and how huge that would be for a project. And then we'll do the problem. So the volume is equal to the area of the base times the height of the 3D object divided by 3. Okay, so let's actually do this. So the area of the base, since it is a square, is 8 times 8 or 64. Times the height is 6.5, we divide that by 3. So we get 416 divided by 3, which is equal to 138.7 cubic feet. So that is how much sand or water, dirt that you would need to fill that pyramid full. All right, so that's pyramids. You find the area of the base, you multiply it by the height, and then divide by 3. You'll notice cones are pretty similar. The pyramid and prism shown have the same base area B and height H as the cylinder and cone. Since the volume of the pyramid is 1/3 the volume of the prism, then by Cavalier's principle, the volume of the cone must be 1/3 the volume of the cylinder. So once again, it's the same equation. It's 1/3 base times height. We just know now, since our base is a circle, that we're going to use pi r squared as our big B. So find the volume of the oblique cone. The only thing that we need to make sure is that our height is at 90, and we have all of our information. So volume is equal to 1/3 pi r squared times height, or you can write it pi r squared times height divided by 3. Plug in your info. Make sure you square first. So you take 9.1 squared times pi, then times 25. we get 6,503.9. Then divide by 3 and you get 2,167.96, or if we round up, 2,168. And this is cubic feet because we have the volume. Okay? Cones are actually very simple. Actually, this whole lesson's pretty simple. So volume, once again, is 1/3 times the area of the base times the height. I'm going to go ahead and do pi r squared times the height divided by 3. Oh, I'm sorry, it's not a 60. That's a 25. Pi times 12 divided by 3. When you solve this, you end up getting 314.16 cubic inches. If you were to leave this in terms of pi by reducing here, you'd actually get 100 pi. That's why this looks like pi, because it is pi times 100. So both of those are valid ways to write the volume, this way and that way. All right, and now we're going to find the volume of the oblique cone to the nearest tenth. It does not really matter that it's oblique because we have the perpendicular height. We just have to find it to the nearest tenth. So volume is equal to base times height divided by 3. Our circular base is pi r squared times height divided by 3. Notice that your radius and your height happen to be the same thing here. So we take 20.6 squared times pi times 20.6. You get a pretty big number, 27,463.22. And then you divide that by 3 and you get 9,154.4. They went to the nearest tenth, so we call that good right there. And lastly, we are going to find the volume of the cone to the nearest tenth. Same equation once again. These are all super simple. Oh, I forgot something. Call it super simple and then not even do it correctly. Gotta divide by 3. Because it's not a cylinder, it is a cone. So we have 64 pi times 15, 3015.93 divided by 3. And our solution then for our volume is 1,005.3 cubic meters. All right, and then this last slide just gives you a summary of the different equations for our prism, cylinder, pyramid, and cone, their volumes, so you can set them up. That's all I have. Have a great night.